There are values that cannot be measured by the speed of modern machinery, but are instead forged through time, patience, and the hands of skilled artisans. Today, RaWMachines will take you across thousands of nautical miles, from the pine forests of northern Europe to the tropical waters of Malaysia, to discover the revival journey of two fading wooden boat-building heritages, the legendary Payene boat and the proud Naga Pilangi. What are you waiting for? Let's dive right in. The craft of wooden boat building, a heritage trade slowly fading away, is being passionately preserved and revived by the builders and apprentices at the Jamsingkoski Vocational School. To build a high-quality boat, one must first secure the right timber. Slow-grown, tight-grained pine is the optimal choice. However, this material is becoming increasingly scarce as modern forests are managed for rapid growth. The raw material is sourced from the Tapio Peltonen farm in Hutia. The trees are felled in late winter while still dormant, the ideal time to ensure the highest quality of the wood.
Tämä on just semmoista tavaraa, kun me saatiin tuolta Länkipuhista, mistä me on tehtykin niitä veneitä.
After milling, the planks are cut to a thickness of about 16 to 17 millimeters, leaving extra stock for final planing, and then stacked with stickers to dry evenly, minimizing warping and splitting. After drying, the timber enters the shaping stage. The bow piece is hewn with a specialized axe to a high degree of precision, ensuring the integrity of the gains for the overlapping planks. Simultaneously, the steering oar is meticulously crafted. Although it seems like a minor detail, it plays a vital role in maneuvering the vessel. The spruce timber used for the oars must be of top quality, not free with dense, uniform grain. Following a rough layout cut with a circular saw, the oar is carefully finished to achieve the ultimate combination of lightness, sleekness, and structural durability. Next, the builder cuts the gains on the bow piece using an axe and a pocket knife, creating the small recesses to fit the hood ends of the planks later on. As the stern piece and the keel are joined together, the backbone of the boat gradually takes shape. The most critical requirement at this stage is maintaining near-perfect alignment. Even a slight twist in the centerline can cause the vessel to lose its track when in operation. To enhance the durability of the joints, the Craftsman uses a highly waterproof adhesive. Beyond securing the components more tightly together, this glue is robust enough to withstand moisture, salt water, and harsh environmental conditions.
Sitten me voitaisiin sitten piirtää se kanssa. Niin.
Before the final finishing steps, the builder uses templates to mark out the design lines for the bow section. These guide marks serve to ensure absolute precision throughout the machining process. The primary focus of this stage is maintaining the perfect integrity of the gains. In wooden boat building techniques, even the smallest leftover splinter can create a gap, compromising the watertight integrity of the hull. Afterward, the surface is smoothed down with a rasp to remove any sharp edges and excess timber. Concurrently, each individual plank undergoes a rigorous inspection. High-quality timber typically features incredibly dense growth rings, measuring around just 1 millimeter per ring. In traditional boat building, many essential tools simply cannot be bought off the shelf. Chief among these are the handcrafted wood scrapers. At first glance, they may appear remarkably simple, yet they dictate the ultimate precision of the mating surfaces between the planks.
Sitten täältä suunnasta tuosta eteenpäin. Meillä on aika paljon sen verran se yläreuna siistiintyy.
This is precisely why boat building has never been a craft of haste. For a skilled artisan, a boat measuring around 5 meters can require anywhere from 75 to 80 labor hours. In a training environment, however, that figure often multiplies several times over. The ultimate goal is not merely to finish a product, but to help apprentices grasp the core ethos of the trade.
Niin saa jonkinlaisen otteen siihen uran puolella. Oikein mahdottomuus muuten auttaa.
With the primary components fully prepared, the assembly of the hull begins with the first strakes. Each plank must be carefully aligned, checking its position and straightness before being fitted into place. To make the timber easier to bend to the shape of the hull, the wood is wetted down to increase its flexibility and reduce the risk of splitting. The lap joints are then sealed using melted pine resin mixed with wool fibers.
Rouva pistelee sen siitä nyt ihan... Langan pitäisi olla tuossa nyt siinä ja sitten pistetään puristi. Mä kokeilen nyt sitten tämän pään taivutusta täällä. Mun tekis mieli oikeastaan tää perä laittaa kiinni, niin tehtäis sitten siellä mitä tehdään.
Onko se menee niin hyvin?
Niin.
With light but precise hammer taps and the aid of specialized clamps, the builder coaxes the hood ends into their proper position. Once the components seat perfectly, they are held fast with high-grip serrated nails. At high-load joints, copper rivets are chosen and tightly clenched to ensure long-term structural durability. From loose, separate planks, a complete hull gradually takes shape, every curve and every joint reflecting the precision and patience of the craftsman. At the Haavisto boatyard, every boat is built according to the traditional Pajan design, 5 meters long, about 1.4 meters wide, and weighing 90 to 95 kilograms when completed. It is a sturdy type of boat with good load-bearing capacity, while also being visually elegant and easy to handle. The material cost for each boat is around 2,000 marka. With proper care, a wooden boat can last as long as 40 to 50 years. A straight, slender juniper tree is the ideal choice for crafting the ribs. Naturally, the harvesting of the timber is carried out only with the explicit permission of the forest owner. To complete a single boat, approximately 17 sets of ribs are required. The wood is then machined into standardized strips, measuring roughly 3.5 centimeters in width and nearly 2 centimeters in thickness. Next, the wooden strips are placed inside a steam box for about an hour and a half. Thanks to this process, the timber becomes highly pliable and can be easily bent by hand. Once the desired shape is achieved over the templates, the builder ties and secures the ribs so the wood can cool down and lock in its design profile. The final result reveals a set of framing ribs finished to absolute precision. Once the ribs have locked into their proper shape, they are installed into the hull using serrated nails and clenched tightly at the plank laps. The bending of the gunnels is also carried out with great care, often prioritizing fresh, green pine to achieve better flexibility. Inside the hull, the interior fittings gradually come together, including the floor runners, oarlocks, brackets, and thwarts. Interspersed between the hours of labor are coffee breaks and light-hearted conversations, a very familiar and cherished part of workshop culture. With the final details put in place and the bow section cleaned up, the boat is virtually complete, both in form and function. Professional rivalry exists in this craft as well. A master craftsman is rarely comfortable openly praising another's workmanship. The most generous compliment they typically offer is simply, "At least it's made from good material." The traditional protective coating for the boat is pine tar, a natural preservative derived from pine, valued for its durability, appearance, and distinctive pleasant aroma. A newly built boat usually requires around 5 to 6 liters of pine tar for surface treatment. After months of crafting, the day finally arrives for the boat to be launched. The ribs that were steam bent back in the winter, along with the completed interior fittings, are now all set for the maiden trial. The sails are hoisted, the vessel's handling is put to the test, and the trial crew perfectly embodies the spirit of the craft. The youth bring their strength, the elders offer their seasoned knowledge of materials, and shared laughter helps wash away the pressure of long hours of labor. The moment the hull touches the water is far more than just a final technical inspection. It is the ultimate connection between the builder, the timber, the ancient craft heritage, and the culmination of dozens of hours of dedicated handwork. Next, join me as we take a look at another boat building project in Malaysia. Malaysia has a profound connection with the sea, and Duyong Island, nestled at the mouth of the Terengganu River, is regarded as one of the last remaining sanctuaries preserving the traditional Malay boat-building craft. There was a time when these intricately carved vessels played an essential role in both the daily lives and the maritime trade of the local community. However, through the passage of time, this age-old handicraft has been gradually fading away. Driven by a desire to preserve these invaluable skills, the local community initiated the Naga Pelangi project in 2003. The project aims to revive the heritage of Malay boat building by reconstructing a full-sized vessel using strictly traditional methods. The construction process begins with Chengal wood. Growing in ancient tropical rainforests, Chengal is renowned for its resistance to termites, exceptional hardness, and remarkable durability. It is no surprise that generations of Malay shipbuilders have chosen this timber for ocean-going vessels. Even so, Chengal is a challenging material. Once dried, the wood becomes nearly impossible to bend, so the planks must be cut while the timber is still green and then left to air dry naturally for about a year before use. Once the material meets the required standards, the hull assembly begins. The keel is laid first, followed by the bow post and stern post. All components are secured with large bronze bolts, the first structural elements forming the foundation for the rebirth of Naga Pelangi. The first plank, the bottom lining plank, is being prepared. This is an extremely important component because it defines the lines of the entire hull. Following traditional methods, the wood is heated directly over fire to increase its flexibility, then gradually bent along the shape that the craftsmen have already envisioned in their minds. As the temperature drops, the plank retains its new form as though it had always belonged there. After the bending stage, the planks are temporarily secured with screw clamps. The craftsmen then continue marking the keel bevel edges, locating the fastening dowels, drilling holes, and repeatedly hand planing and adjusting until every surface fits together perfectly. One of the most distinctive features of traditional Malay shipbuilding is the limited use of metal in the structure. Instead, builders rely on pasak, wooden dowels crafted from panaga, a reddish ironwood renowned for its exceptional hardness and density. Around 100 wooden dowels are driven along the keel, and every hole in the planking must align with them with near-perfect accuracy. The material is so hard that tools frequently need to be resharpened throughout the process. Working alongside the pasak system is the traditional caulking technique using kulit galam, bark from the melaleuca tree, used as a waterproofing layer between planks. While Western methods employ cotton, oakum, or mastic, Malay builders thread strips of bark through the wooden dowels, creating a thin cushion of roughly 1 to 2 millimeters between the joints. The solution is both simple and remarkably effective. It allows the hull to expand and contract naturally with changing climatic conditions while maintaining durable waterproofing through many years of service at sea. At the center of the hull, 2 temporary wooden frames are erected, revealing the vessel's overall form. But what truly stands out is the assembly sequence. While European methods typically build the frame first and add the planking afterward, the Malay approach follows the exact opposite path. The hull shell is shaped first, and the framing system is only added later. This reverse framing technique not only reflects a technological difference, but also expresses a distinct Malay philosophy of boat building, one in which inherited craftsmanship holds a role no less important than any technical blueprint. A support frame is erected to position the crucibles for casting the ballast keel. For typical cargo ships, the cargo itself acts as ballast, making external ballasting unnecessary. However, because the Perahu Besar is designed for tourism and leisure, most of the ballast is moved outside the hull to optimize interior space. This solution also offers a distinct stability advantage. Lowering the vessel's center of gravity increases its righting moment against the lateral pressure exerted by the sails. The lead ballast block is secured using copper bolts pre-cast into the structure. Once the mold and pouring spouts are fully assembled, the lead bricks are melted down, the valves open, and the molten metal floods the mold. The end result is a solid ballast keel with a total weight reaching up to 10 tons. As the overall silhouette of the ship becomes clear, the finishing of the outer hull begins. The Hellas rub rails are fitted to provide impact protection while establishing the distinctive, sweeping lines of the hull. Inside, the framing system continues to be integrated and built up alongside the subsequent layers of planking. To reinforce the entire structure, approximately 15,000 silicon bronze screws are utilized. These screws are countersunk into the timber, then plugged with wooden bungs and epoxy mastic to safeguard the fasteners against moisture, while keeping the ship's surface clean and seamless. After nearly a year of continuous labor, the hull framing and the final longitudinal stringers are at last complete. This marks the beginning of the stern tube installation, the component responsible for transferring power to the propeller. The shipwright must pinpoint the exact alignment for the stern tube, then bore a long, straight hole directly through the stern post. This task allows virtually no margin for error, as even a minor misalignment could compromise the vessel's entire propulsion efficiency later on. Once all the mechanical components are properly seated, the bolts and connection points are coated with a protective green anti-corrosion paint to withstand the harsh marine environment. The vessel now truly begins to take on the definitive shape of a seaworthy machine. Now, the craftsman begins carving the figurehead for the bow, traditionally a goil or gable figure, representing the Naga, a half-dragon, half-serpent creature that historically served as a guardian deity in Malay maritime culture. Over time, this symbol has evolved. Under the influence of Islamic culture, the intricate mythological carvings were gradually simplified into subtle, stylized lines, yet they retain their full symbolic significance. From selecting the timber and aligning its position to shaping, sanding, and applying the primer coat, every single step helps finalize the face of the vessel, where technical craftsmanship, ancient beliefs, and Malay seafaring identity converge upon a single block of wood. As the hull nears completion, the interior spaces begin to take shape. The wheelhouse is installed, bulkheads are erected, and the cabins are finished with handcrafted solid wood details. In tandem with this, work progresses on the deck treatment. The surface is sealed with waterproof epoxy and coated with protective paint before the final timber decking strips are laid over it. Living amenities, including skylights, a spiral staircase, and a central cabin configured with single and double berths, are also gradually completed. After years of meticulous crafting, the defining moment finally arrives, moving the vessel out of the shipyard and into the river. In the past, this monumental task would have relied on the collective strength of the entire fishing community. However, for this project, heavy machinery is mobilized to assist in moving the massive structure with greater safety and precision. The ship is positioned onto a system of launchways, with round logs placed underneath to act as traditional rollers. Bit by bit, it is winched down toward the riverbank in a manner that seamlessly blends modern execution with echoes of ancient techniques. Yet, even upon reaching the water's edge, the vessel must wait. The precise moment of launching depends entirely on the spring tide, when the water level rises high enough to safely float the hull into the previously dredged channel. In the seafaring trade, nature always retains the final word. After 3 years of painstaking craftsmanship, the Naga Palangi is finally launched, a milestone marking the triumphant success of a dedicated revival effort. With the launch successfully executed, the slipway cradles are dismantled, and the vessel is towed into deeper waters to undergo further outfitting. The next critical phase is the stepping of the masts, the components that will bestow upon the ship its true identity as a traditional Malay sailing vessel. The iconic red traditional sails are hoisted, striking a bold silhouette against the sky and water. It is an image that was once common across local waters, yet had been entirely absent for decades. Now, those sails catch the wind once again aboard the Naga Palangi. The ship is not only ready to embark on new voyages, but has transformed into a living symbol for the resurgence of a centuries-old maritime heritage, where ancient techniques, cultural memories, and the enduring spirit of Malay seafarers are once again carried out to the open sea. Opening the cut and creating the face. Notch. The journey begins in the forests of the Pacific Northwest, where nature preserves some of the purest raw materials for the maritime industry. Using a high-powered chainsaw, the logger makes precise horizontal and angled cuts at the base of the tree. Once the shaping cuts are complete, he uses an axe to pry away the excess wood, creating a clean face notch. Deepening the cut and site preparation. Next, the saw blade continues cutting deeper into the trunk to create space for supporting equipment. Large wood sections are removed using axes and manual force, while every centimeter of the surface is carefully refined to ensure the installation area is flat, stable, and capable of handling the load. Installing the hydraulic jack. What makes this project distinctive is the use of a specialized hydraulic jacking system to control the direction of the fall. At the same time, plastic wedges are driven into the back of the cut to prevent the trunk from pinching the saw blade, while also generating the initial pushing force that begins shifting the tree away from its natural balance point. Coordinating force and completing the cut, the logger returns to the chainsaw to perform the felling cut from the opposite side. Meanwhile, his partner continuously increases pressure within the hydraulic system. The precise coordination between severing the final wood fibers and the growing force from the equipment gradually shifts the tree's center of gravity toward the pre-calculated direction of fall. the decisive moment. The sound of wedges being hammered echoes sharply through the silent forest. The wood fibers begin to crackle, a sign that the trunk can no longer support itself. Then, the decisive moment arrives. The ancient tree slowly leans, its massive silhouette gradually falling exactly into the intended position, ending with a thunderous impact. At that moment, it completes its role as a living presence in the deep forest, preparing to begin a new chapter in its existence. Now, the massive logs are loaded onto specialized trucks, beginning their journey toward the Collins sawmill. Each transport run is a true test of skill. The driver is not merely controlling the truck itself, but also managing the enormous weight trailing behind. Sharp bends, slippery roads, and unpredictable terrain mean that every maneuver demands absolute concentration and many years of experience behind the wheel. The scene before us is the log yard, often described as the raw material bank of the Collins sawmill. Here, every log carries its own distinct identity. They are marked, classified, and recorded with detailed data to ensure the mill maintains a stable supply of raw materials, regardless of changing weather conditions or the uncertainties of the deep forest. Leaving the storage yard, the logs roll down the line toward the debarking machine. This heavy machinery swiftly strips away the rough, rugged outer bark, exposing the bright, smooth wood core hidden underneath. Yet, that stripped bark is far from being treated as waste. It is carefully recovered and repurposed as a valuable resource, serving as biomass fuel, agricultural mulch, or raw material for the pulp and paper industry. And then comes the core stage, sawing and milling. For smaller logs, the process moves quickly through the single-pass saw system. With a single cut, the round log is instantly transformed into perfectly straight boards. for massive trunks, the real challenge is only just beginning. At the head rig system, steel saw blades stretching dozens of meters are tensioned like instrument strings, weighing hundreds of kilograms and operating at extremely high speeds. The sound of the blade meeting the wood is sharp and powerful. Each cut passes through trunks more than a meter thick without the slightest vibration. Even a minor alignment error could ruin an entire log. But here, modern sensing technology combined with precise human control keeps the entire operation under perfect command. After the initial breakdown stage, the timber continues to the resaw process, where it is cut down into standardized dimensions suitable for boat building. In the past, crude sawing techniques could waste up to 30% of a tree's value. Today, optimization technologies have pushed utilization rates beyond 90%. That means nearly the entire trunk is transformed into useful products.
Perfectly straight, you know, it's kind of a pain, but it is a cool machine though, that's for sure.
Watching the boards continuously emerge from the conveyor line, we see more than just timber. We see the culmination of precision engineering, where mechanical power has been controlled and refined to serve a single purpose, extracting the full value that the forest has provided. Not every log emerging from the forest is perfect. Over decades of growth, trees must endure storms, steep terrain, rocky ground, and countless environmental pressures. As a result, trunks often carry unavoidable curves, twists, or deformations. To address this challenge, Collins employs a specialized technology, the curve gang saw. Unlike traditional straight saw blades, the curve gang saw is designed to adapt its cutting path to the actual shape of the wood. When a curved log enters the machine, sensors and software immediately scan its form and send control signals to the blade assembly. Within moments, the entire set of blades adjusts its position, effectively bending to follow the natural curve of the trunk. And the result? Instead of forcing a curved log into a straight cut, each board is produced in alignment with the wood grain, making it stronger and more visually appealing. It is a clear expression of one principle. When we learn to listen to and respect nature, we achieve the best possible result. Leaving the primary head saw, the boards still carry waney edges, bark remnants, and irregular profiles. At the edger station, these rough bark-covered margins are completely ripped away, replaced by perfectly straight, parallel edges. It is in this exact moment that the timber truly transforms, gaining flat faces, crisp square corners, and clean, sharp lines. The rough log is gone. In its place is true dimensional lumber, ready for its next journey, to be joined, fastened, and built into structures that will stand the test of time. After edging, the lumber continues on to the bin sorter. Optical sensors and high-resolution cameras scan each board in an instant, precisely measuring its width, thickness, and length. The computer system rapidly determines the grade and dimensions of each board, after which the automated mechanism smoothly directs it into the appropriate sorting bin. This is the moment when timber ceases to be raw material and officially becomes an industrial product with clearly defined specifications. If sawing represents strength and muscle, then the kiln embodies the mill's quiet patience. Fresh timber contains a large amount of moisture. Without proper treatment, it will warp or decay when exposed to the harsh conditions of the open sea. The wood is placed inside the kiln, where temperature and humidity are precisely controlled by computer systems through cycles that can last more than 10 days. When the process is complete, the wood takes on a light golden tone, the grain becomes clearly visible, and it produces a clear, resonant sound when tapped, signs that the fibers have reached complete stability. Passing the tests of time and fire, the timber enters its final stretch, finishing and inspection. If the colossal saw blades represent the raw muscle of the industry, the focus here shifts entirely to precision and refinement. The first stage is planing. High-speed rotary cutter heads glide across the surface, shaving away the fuzzy outer layer and completely erasing any rough saw marks left behind from the previous steps. In just a few brief seconds, a stark transformation takes place. The true character of the wood grain emerges, smooth, crisp, and rich with depth. This is no longer just an anonymous piece of lumber. It has officially become a premium product with a story of its own, forged over decades of growth in the deep forest. Though modern machinery dominates the facility, at the grading station, humans remain the final authority. The graders rely on their eyes and decades of accumulated experience to inspect every knot and tiny crack. They judge not only with sight, but also with experience and intuition forged over many years. The grade stamp applied to a board is more than just a technical classification. It is a commitment to the craftsman's reputation and integrity, guaranteeing that every selected plank meets the standards required to protect the vessel on the open sea. The trimmer system performs the final standardizing cut. Any cracked, damaged, or inconsistent sections at the ends of the boards are completely removed. This is the last cutting stage, ensuring that every piece of timber reaches absolute consistency and finish before leaving the industrial production line and entering the boatyard. The timber is stacked by a stacker system. The neatly aligned bundles are tightly secured by a bander using steel or plastic straps, keeping them stable throughout transportation. Finally, each bundle is wrapped in moisture-resistant paper, labeled and assigned a traceability code, a kind of passport for the timber. From here, the boards are ready to leave the mill, traveling by truck, rail, or shipping container across the United States and around the world. They will become house frames, flooring, furniture, and stand firm for generations. That moment closes one journey, but at the same time begins another. Now, the timber will be transported to the Cornwall boatyard to witness the construction of the Greyhound. The Greyhound project officially began on March 1st, 2011, at Chris Reese's workshop in Millbrook. The first months focused on crafting the massive skeletal framework. We see the craftsmen carefully carving and joining curved structural timbers, laying the foundation for the shape of the traditional lugger. By late July, the team moved into a larger workspace at Southdown. During August and September of 2011, Greyhound's skeleton gradually emerged in proud form. Each rib was erected along the keel, defining the vessel's spacious hull structure. In October 2011, the shipyard entered its most critical and labor-intensive milestone, hull planking. This phase demands extreme patience and precision. Long, thick wooden planks must be carefully coaxed and bent along the complex, sweeping curves of the frames. Layer by layer, the strakes are tightly fitted edge to edge, running flawlessly from stem to stern, transforming the hollow skeleton into a watertight hull. Throughout the freezing winter months of early 2012, the Greyhound's hull steadily closed up, sealing the gaps between the timber ribs. The crew worked meticulously at the stem and stern, demanding convergence zones where the planks meet, requiring master-level joinery to ensure a sleek, hydrodynamic entry and exit through the water. With the outer shell fully planked, March and April 2012 saw the team shifting inward to install the heavy deck beams and bulwark stanchions. This vital step bridged the open hull sides, transforming the Greyhound from an empty shell into a rigid, multi-layered maritime structure. Throughout the summer of 2012, the boatyard became busier than ever. Although the camera failed in May, progress was still documented through still photographs, sanding, coating, and sealing operations. The hull was painted dark brown above the waterline and dark gray-black below, giving it a powerful and durable appearance. June and July of 2012 marked Greyhound's visual transformation. The upper hull received multiple coats of dark brown protective paint, creating a classic and distinguished appearance. The underwater hull was coated black with a specialized anti-fouling finish. At the same time, Craftsman shaped the massive masts from solid pine trunks. Each mast was planed smooth, polished, and treated with preservative oil to withstand the tension of wind-filled sails. On August 4, 2012, Greyhound officially touched the water. Amid the cheers of the crowd and the presence of craftsmen dressed in traditional naval attire, the vessel slowly left its supports and slid gently into the bay. It was the rewarding culmination of more than a year and a half of relentless labor, marking the beginning of Greyhound's new voyages. When Greyhound completed its journey from timber framework to launch day, another story began, one in which hull curves are shaped through modern engineering and an unchanged pursuit of perfection. The process begins with an extremely flat, rigid support platform built across the workshop floor. Wooden frame molds are cut directly from technical drawings and erected vertically to define the hull's form. Next, longitudinal beams are attached to the frame structure before long planks are laid along the hull. Each plank is bent to match the vessel's contours and secured by hundreds of manual clamps. Layer upon layer of thin timber creates a shell that is not only lightweight, but significantly stronger than solid wood. Once the wooden shell is completely enclosed, the craftsmen begin the hand sanding stage to eliminate every uneven surface. They then apply a layer of epoxy resin and the vessel's characteristic green fiberglass. This skin binds the wood fibers into a unified structure, resisting saltwater corrosion and preventing the intrusion of marine fouling organisms. At this point, the vessel resembles a giant green figure resting quietly upon its cradle. April 2016 marked an important milestone. The hull was moved out of the workshop for the first time. In a highly technical operation, the entire structure was lifted and rotated 180 degrees in midair. This moment not only revealed the hull's complete lines and curves, but also marked the transition to the interior construction phase. After the rotation, the vessel was placed onto a new support frame in its true operating position, ready for interior finishing work. Bulkheads are installed. These are not merely partition walls, but critical structural elements that prevent the hull from deforming under wave pressure. The beam framework for the deck is assembled, forming a complex wooden network across the top of the vessel. From late 2016 into early 2017, the Ventus workshop no longer resembled a rough construction site, but instead became a gallery of high-end maritime woodworking craftsmanship. Mahogany takes center stage during this phase. With its distinctive deep red color and rich grain pattern, the material covers much of the interior space, creating an atmosphere that is both luxurious and deeply rooted in traditional maritime aesthetics. Many surfaces are completed using the book matching technique, where mirrored timber panels are joined to preserve the natural continuity of the wood grain. Every cabinet compartment, cabin section, berth frame, and storage element must be crafted to match the unique curvature of the hull. There are few right angles or simple flat surfaces. Almost every component requires measuring, cutting, and adjustment to blend into the vessel's complex geometry. Even small details such as decorative grooves, handles, and joints are hand-finished, while still meeting the very practical demands of the marine environment. Moisture resistance, vibration tolerance, and durability over many years of operation. This phase marks an important transition from completing the interior hull to working on the upper deck. The craftsmen begin constructing the coach house, the defining feature of the vessel's appearance. Thick mahogany planks are heat bent to fit tightly around the cabin framework, creating curves that are both graceful and exceptionally strong. Each cabin window frame is hand-grooved with precision to ensure resistance